Hello and welcome back to Digital Earth Africa. Here at Digital Earth Africa, we're constantly working hard to enhance your experience based on your valuable feedback. And today, we're excited to introduce a new capability that many of you have been eagerly awaiting. And this is the ability to define the area of interest in a sandbox notebook using a vector file. So previously, defining an area of interest in the sandbox required specifying a point, which is a latitude and a longitude, and a buffer around that point. While this method served its purpose, we have realized that it has limitations and it has posed challenges for some of our users. So we listened to your feedback and we've now introduced a more flexible way of defining an area of interest, which I will be taking you through in this video. So this new way of defining an area of interest comes in the form of a module that contains a function called define area, which can be used to define an area of interest for analysis in the Digital Earth Africa sandbox. So the function takes in either a point and a buffer or a shapefile or GeoJSON file as input to define the area of interest. So this is a powerful feature that provides you with a more flexible and precise way of specifying your desired geographic boundaries, because by leveraging vector files, you can now define areas with intricate boundaries, making your analysis more accurate and insightful. So in this video, I'll do a walkthrough of how to use this function and how to add it to your existing notebooks. In order to showcase this ability or this capability of using vector files to define your area of interest, I've created an example notebook that I will be taking you through today. In this example notebook, I will go through all the necessary steps that you require to take full advantage of this function that we have created. But before I continue, I should just point out that most of the real world examples notebooks, which I'm going into that folder now, have this capability already added. For instance, the burnt area mapping notebook already has this way of adding or defining an area of interest included in the notebook itself. But we do understand that some of you might want to add this capability separate to those notebooks. So I will be taking you through how to do that. So now I'll just go back to our real world example, to our example folder, and do a walkthrough of how to use this capability. In order to use this capability, it is important that you make sure you have all the necessary packages imported. Three very important packages that are specifically required to work with the define area function are the GeoPandas package. So this package will allow you to work with the geospatial vector data, such as reading and manipulating shapefiles or GeoJSON files. There's also the geometry class from DataCubital's geometry, which is used to create a geometric representation of the area of interest polygon. And of course, most importantly, we have the define area function, which we are importing from the area of interest module that is contained within the DE Africa tools folder. So if we were to go into the tools folder and DE Africa tools, you'll be able to see the area of interest module, and if you open it, that's where you will see the define area function, which takes either latitude, longitude, and buffer, or a shapefile path, which is essentially a path to your vector file. So I'll just close that and go back to our example folder. So you obviously notice that there are additional packages that are included, but these are not necessarily required for the define area function, but they are required for other functionalities within the notebooks that are required for this particular example. So once you have all the necessary packages that you need. You then need to define your area of interest. And as I've said before, there's two ways of doing it. The first one, which I will take you through first because it's the easier one and the more familiar method, is by using the latitude, longitude, and buffer. So as you can see, the line that corresponds to this method, which we're calling method 1, is not commented out. So it's a line that can be executed. But we see that the line that corresponds to method 2 is commented out. So this is just to say that in this particular example, we're using method 1, which is the latitude, longitude, and buffer, instead of method 2, which is the vector file. So when we do run the code, we will be using the method that we're more familiar with. So what that does then, you just need to provide it with the appropriate latitude and the longitude and the buffer. By it, I mean provide them to the define area function. And then you go ahead and create a geopolygon of that bounding box that you created for your area of interest, and then create a geodata frame from which you can extract the latitude range and longitude range, because these do come in handy when you want to use the display map to display your area of interest, and they can also come in handy in your query for loading your data. For instance, here where we load the Sentinel-2 data, you can use the longitude and the latitude. But if you don't want to use that, you can also use the geopolygon. They do exactly the same thing. So it just depends on your preference and whether or not you have actually extracted the latitude range and the longitude range. So if you haven't, you can just go ahead and use the geopolygon. It does or covers the exact same extent. So now I'll just run this code line by, block by block to show what it actually does. So you're importing your required packages, and now you define your area of interest using your latitude, longitude, and buffer. So you always need to specify these three or else you're going to get an error. So I just run that, and that runs, and I just display the area of interest using the latitude and longitude range that I extracted there from my geopolygon geodata frame. And we can see that our area of interest is Lake Chivero in Zimbabwe. Now I want to show you how this then loads the data for that area of interest, but you are actually familiar with this method because this is how it's been done previously, but I will just show it in any case. So I'll connect to the data cube, and then obviously create my reusable query so I can get my Sentinel-2 data for that time range for the geopolygon, or if you want the X and Y ranges, but in this case I'll just go for the geopolygon and the measurements that I want and the resolution. So then I just load it using the load ARD function. This might take some time, but obviously we just need to be patient and wait for that. But it will just load or extract or get the data for our area of interest, that is Lake Chivero in Zimbabwe, for that exact shape. So that is what we're doing. That's what we're waiting to happen here. So we'll just give it a few moments for that to happen. So now we see that it's done, and I'm going to plot the RGB of the first image in this time frame just to see what it actually looks like. So we'll run that. And we can see it got us the Sentinel-2 data for that extent that we defined using our area of interest function. Okay, so now I will show you what needs to happen in order for you to use the second method. First of all, I'm just going to clear and restart the kernel. So we have nothing else on there. So what you need to change in order to use method 2 is you have to put a hash in front of that line that corresponds to method 1, because we don't want to use that anymore. And now we have to remove the hash in front of the line that corresponds to method 2. But the thing is, we actually need to bring the shapefile for Lake Chivero into our sandbox. So we can't actually get it straight from our file explorer onto here, but rather we have to upload it. So let me just go back actually. So using this file upload button up here on the top left, we need to upload our area of interest, which is a shapefile. So when it's a shapefile, you need all the files. So you need to select all the files and add them. So you can't just add the .shp file. You need all of the files. So we upload it into our example folder. So now we see it's there. So here, that's what you would call it. So if it was a different name, you would change the name to whatever it is. If it's a GeoJSON, you can change it to a .geojson file. But everything else remains the same. So we'll just run it the same way we ran when we were doing method 1, method 2. See, our area of interest is still Lake Chivero, but we see that the shape is a bit different. And that's because it's taking the extent of the shapefile that we added. And if we want to see what that shapefile looks like, we actually can. So if we just add geopolygon, so we see that is actually the shapefile, what it looks like. So this here just takes the overall extent that is covered, so not the exact shape of the area of interest that we uploaded, but we will take care of that later. So same steps still stand. So we connect to our data cube, and the same still applies here. But it's important to note that when you load your data, your Sentinel-2 data, it's not going to be loaded for the shape of your shapefile, but rather it can only take the latitude and longitude range, or the geopolygon, which is going to be this shape, not the shape of the area of interest. And I will actually just show this to you. I'll run it, and this once again will take some time. So when you load your data for your area of interest, when you're using the vector file, it is important that you know that the data does not automatically align with the vector that you uploaded. It typically represents a larger area that encompasses the bounding box that is defined by the latitude and longitude range or the geopolygon. So this means that when you add the data, it may contain pixels that are outside the boundaries of the uploaded vector or polygon. And to ensure that the analysis is performed only for the shape, this shape that we've uploaded, an additional step of clipping will be required, and that is something that I will be showing you. So we see now that we've loaded our Sentinel-2 data for our area of interest, and once again, when we view the first timestamp as an example of what is actually loaded, we see that it's not the shape that we want, but rather the bounding box. And that is now where we need to do the clipping. So the clipping involves overlaying the loaded shape with the area of interest and keeping only those pixels that fall within the boundaries of the shape. And by doing that, we ensure that the analysis that we perform afterwards is only specific to our area of interest. So this is where this code comes up, the rasterizing and the subsequent clipping. So a geopolygon, which is what the load ARD and also the dc.load function that we use to load our area, our Sentinel-2 data or any of the data within the Digital Earth Africa platform, it only takes a geopolygon or the XY ranges, which are essentially a geopolygon, and it's not the exact shape that we want. So we need to clip, and to do that, we take our geopolygon geodata frame that we calculated here, or that we extracted here, from which we got the latitude and the longitude range. We need to take that shape and rasterize it so we can use it to mask this area to just the shape of the polygon. So that is what this code is doing. So we rasterize the geopolygon and then we mask DS, which is our Sentinel-2 data that we loaded here. We mask it to where our rasterized area of interest is equal to 1. So that means where, so only to restrict it to the areas within the boundaries of this shape that we uploaded here. So when I run that, and then I do the same thing I did here to showcase the first timestamp, we will see a difference in that now it's clipped to the exact shape of the study area. So that is how we have added or thought to bring this capability into the Digital Earth Africa sandbox. So you can upload your area of interest as a shapefile or a GeoJSON and use method 2. And by doing that, you'll be able to load the data for the outer extent of the shapefile or the GeoJSON that you uploaded, but we do give you the ability to clip after rasterizing that geopolygon and then continuing with your data clipped to the exact shape of your study area. So this is how you would use the area of interest module, which contains the define area function. It's pretty straightforward, and it's already included, as I said, in some of the real world examples. I'll just open another one. So for instance, the chlorophyll monitoring, you'll see that this capability is also already added in here. So if you need a reference, you could always open some of the examples in the real world examples to see how this methodology or how this capability was used in the notebook. But this is just a brief overview of the capability itself, how you can add it. Remember, you need to make sure you have the necessary packages, and you need to decide whether you want to use method 1 or method 2. Remember, the order really doesn't matter, but you just need to decide if you want to use the latitude, longitude, and buffer, or you want to use a vector path, which you first have to load into the sandbox in order to use. And if you do use a vector file, it is important that you clip your resulting data after you've loaded it to the exact shape, because unfortunately when you load it, you can only load it for a geopolygon or for the extent or bounds of your area of interest, and not for the exact shape of your area of interest. So clipping, when you use a vector to define your area of interest, is really important to make sure you restrict your subsequent analysis to that area of interest. So that is the new capability that we have added, and we hope this will make analysis in the Digital Earth Africa Sandbox more easier, and make it easier to just work with notebooks within the platform. So remember, we still have our courses that you can enroll in. So you can do the introduction to Sandbox, you have the master classes, we also have videos, tutorials, and manuals that you can use in English and French to help you get more familiar with the Digital Earth Africa platform. You can also learn more about us through our website. We also have a help desk where you can subscribe to the Digital Earth Africa community to receive quarterly newsletters and invitations to attend events. And you can also sign up for our weekly live sessions every Wednesday at 11 a.m. So thank you so much for listening. We hope this new capability is something that can be useful in your analysis within the sandbox. Thank you.